Welcome students. Let's start with our second part of surface chemistry, in which we are going to discuss colloidal solutions, emulsions, and a few examples based on the concepts that we discussed in the first part as well as the second part of surface chemistry. Colloidal state. The substances can be classified into three types depending upon their particle size, and therefore the solutions they make can also be classified into three types. So the first one is the true solution, in which the size of the particle is less than 1 nanometer. Now 1 nanometer is equal to 10 raised to minus 9 meters. The second type is the colloidal solution, in which the particle size is between 1 nanometer to 100 nanometer. And the third type of solutions are the suspension, in which the particle size is greater than 100 nanometer. Colloidal solutions are the solutions of our interest. So we can define a colloidal system as a heterogeneous system which consists of a dispersed phase and a dispersant medium. There are basically 8 types of colloidal systems depending on the states of the dispersed phase and the dispersant medium. I hope you can recall that we also discussed the types of colloidal systems in the states of matter. So in case the dispersant medium is solid, there can be 3 types of colloidal systems based on the various states of dispersed phase. When a solid is dispersed in the solid medium, the colloidal system is known as solid sol. Its example is cranberry glass, in which gold chloride is dispersed in the solid dispersant medium, that is silica. The next example in which the dispersed phase is liquid is known as gel. The example is gelatin, in which liquid is dispersed in the solid dispersant medium. And the third type of colloidal system is solid foam, in which gaseous dispersed phase is dispersed in solid dispersant medium. For example, styrofoam, in which air is filled to make it foam. In the second type of dispersant medium, that is the liquid medium, if the dispersed phase is solid, the colloidal system is known as sol. For example, ink, in which solid dye particles are dispersed in liquid medium. Emulsion is the colloidal system when liquid dispersed phase is dispersed in liquid medium. For example, milk. The third type is foam, in which the dispersed phase is gaseous. For example, shaving foam, in which air is dispersed in liquid dispersant medium. Now, if the dispersant medium is gas and the dispersed phase is solid, the colloidal system is known as solid aerosol. For example, smoke, in which solid particles are dispersed in gaseous medium. And if the dispersed phase is liquid and the dispersant medium is gas, the colloidal system is known as liquid aerosol. For example, fog. Two gases are always completely miscible in all proportions, therefore they do not form a colloidal system, they form a true solution. There are various terms that we get to hear in relation to the colloidal systems. One of the most common terms is sols. So those colloidal systems in which the dispersant phase is solid and the dispersant medium is liquid are known as sols. In hydrosols, the liquid medium is water, whereas in alcosols, the dispersant medium is alcohol. Lyophilic colloids. Lyo means solvent and philic means loving. So the meaning of lyophilic is solvent-loving colloids. We can define these colloids as those substances that directly pass into the colloidal state when brought in contact with the solvent. That is, those substances which readily form colloidal solutions. For example, proteins, starch, rubber, etc. These colloids are pretty stable because the attractive forces between the particles and the dispersant medium are very strong in their case. They are also known as reversible sols because on evaporating the dispersant medium, the residue that is obtained can be easily passed into colloidal state again by simply agitating it with the dispersant medium. Lyophobic colloids. Lyo means solvent and phobic means hating. So their meaning is solvent hating colloids. They are called such because These substances do not form the colloidal salt readily when mixed with the dispersed medium. The colloidal salts thus obtained are less stable because they can be easily precipitated by adding even a small amount of the electrolytes. And when the precipitate obtained is agitated with the dispersed medium, we do not get the colloidal salt back. Therefore, they are also known as irreversible salts. Based on the particle size, the colloids can be further classified into multimolecular colloids, macromolecular colloids, and associated colloids. Let's take up the properties of these colloids one by one and see how they are different from each other. The first type are the multimolecular colloids. Multimolecular colloids can be defined as those colloids in which the individual particles consist of an aggregate of atoms or small molecules with molecular size less than 1 nanometer. These particles are held together in the colloidal system by van der Waals forces, and the examples are salts of gold atoms and sulfur molecules. The second type are the macromolecular colloids. These are those colloids in which the particles of dispersed phase are sufficiently big in size. The particles are much bigger. For example, the colloidal solutions of starch, cellulose, protein, etc. And the third type are the associated colloids. These are those colloids which behave as normal electrolyte at low concentration. Now let's see what are the various methods of preparation of lyophobic and lyophilic salts. So first of all, we are going to take up lyophobic salts. The three main types of methods are the chemical methods, physical methods, and dispersion methods. In chemical methods, we are going to see how they are prepared by oxidation, reduction, hydrolysis, and double decomposition. Physical methods consist of solvent exchange and physical cooling, and in dispersion methods, we are going to see how they are prepared by mechanical dispersion, Briggs arc method, and peptidization method. So let's start with the first chemical method, that is oxidation.